and the x squared was one of those. But we need to be able to graph it and answer questions about it no matter what form it's given in. So, first question, if I say a quadratic, what does its equation look like? Yeah. Okay. We're not solving it, so it's just any function of the form f of x equals ax squared plus bx plus c. So, in that first box, you're just writing what I highlighted in yellow. And we know the graph of it, I had somebody drawing it with their finger, the graph of it is what? What do we call that shape? Oh, come on. A parabola. Yeah. Okay, did everybody get this written down? Yeah. Okay, so that's our function, our equation. The graph is a parabola. And parabolas can either open up or down. And we saw that before. And that's what determines if they have a maximum or minimum point. So if I have a parabola opening up, does it have a maximum or a minimum? Minimum. If it opens down, it has a okay, that highest or lowest point, it's the max or min. What else is that called? It has a special name. The vertex. So that highest or lowest point is called the vertex. And when you graphed these last year, you talked about the vertical line that would go through the vertex because the graph is the same on both sides of that. What do we call that vertical line? Anybody remember?
The origin?
The axis of symmetry. So it's a vertical line that cuts the graph in half. It's the same on both sides. All right, in terms of graphing it, our strategy is going to depend on, a little bit on how the quadratic is written. Standard form is that form that we just wrote down. That f of x equals ax squared plus bx plus c. Vertex form is what we were seeing on our last test when it was written so that we could do transformations. The vertex can be found just by our transformations. We know it would move right h and up k. So all of our transformation rules are still true. Paper. F of x equals x squared plus 4x minus 4. Can we use transformations to graph that?
Yeah.
Some of them we can. Is this one written like, do you know left or right, up and down, how far we're moving on that one? No. So let's go back to our standby. If we don't know what else to do, we can always plug in points. Let's see if we can figure out the graph of this, since we don't know how to do transformations on it. If you plug in a 0 for your x, what do we get out? We're just going to do as many points as we need until we get a graph. If I put in 1, I get 1 plus 4 minus 4. If I put in 2, I get 4 plus 8 minus 4. So that's 8. What should I plug in next? Okay, let's plug in some negatives. If I put in negative 1. Negative 1 squared is 1. Minus 4 minus 4, so 1 minus 8 is negative 7. So negative 1, negative 7. All right, we already know this should look like a parabola. Does it look like a parabola yet? No, we need more points. If I put in negative 2. Negative 2 squared is 4 minus 8 minus 4 gives me negative 8. Okay, I don't really have a parabola until it bounces back and starts going the other direction. So we need more. If I put in negative 3, we get 9 minus 12 minus 4, which is negative 7. So now we're finally starting to see it. If we did one more, if I put in negative 4, we get 16 minus 16 minus 4. So negative 4. Hopefully yours are a little bit straighter than mine. Okay, so we have this graph. What's the downside of picking points? Was I able just to pick 3 magical points and be done? No, I had to plug in points until I found when my graph changed direction. What's that point called? What did we say? We had to plug in points until we found the vertex. Now, if my vertex had been at like negative 3.5, would we have probably found it doing this? No, so it's very time consuming. So this is not a good option for us. Let's go ahead and answer a couple questions. What's the domain of this? What's our range?
Negative 8 to infinity.
Does this function have a maximum or a minimum? Let's go ahead and answer that. Minimum. Okay, so it had a lowest point, and we knew that because it opened up. How did we know? Could we have known from the original that it was going to open up?
Yes.
How?
Because there's a negative 4.
And it's that x squared. It is a positive x squared. So if it were a negative, that flips it upside down. Positive x squared is flipping up. Okay. What if I asked you to list those maximum or minimum points? Those are called the extreme points. So we just said this one had a minimum. The actual minimum, the minimum value is the y value of that. So I'm going to go right down to example 2 beneath it while I'm on this. So this one had a minimum of, what was that lowest y value? Negative 8. Now if I asked you when that happened when x was what?
Negative 2.
Right. So the actual max or min is the y. If I ask you where it happens, that's the x value. All right. Let's graph some more of these. So for B, this one we could do transformations. Now, if I'm going to have you graph something by transformations, what do you think I expect you to do first?
Graph the original.
I want the parent function. So x squared. 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1, 1, negative 2, 4. If you wanted, you could do 3, 9, and negative 3, 9. You have to have at least 3, but more is always better. Okay, my transformations here. What does a negative do? And what's the 2 do? We multiply by 2. What's that doing?
Subtraction.
Mm-hmm. Another way to think of it, outside is y does what it says. We're just taking our y's times negative 2. So here my y is 0 times negative 2 is still 0. Here my y is 1. 1 times negative 2 is negative 2. Here my y value is 4. 4 times negative 2 is negative 8. Okay, the other side, my y is 1 times negative 2 is negative 2. My y is 4 times negative 2 is negative 2. So it should look What's the domain of that one?
0 to,
Domain is the x, left to right. The range is my y. Now that one's coming from,
negative infinity.
and 0 we get a bracket because we do hit it. Does this one have a maximum or a minimum point? Maximum. So if we want to go ahead and answer that, it has a max of y equals what value? 0. When x is equal to what?
0.
Okay. So my highest point is 0, and that happened when our x was 0. So if you're using transformations, I expect the parent function to be drawn. Let's look at C. So we could do this one by transformation. What's my parent function? X squared. 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1, 1, negative 2, 4. What's the minus 3 going to do to my graph? And the minus 1? I take each of these points, right 3 and down 1. What's the domain of that? What's my range?
Negative 1 to infinity.
Okay, if we look back down at example 2, does this one have a max or a min?
Minimum.
Minimum. What is that smallest y value? Negative 1. When x was equal to what? Okay, so if things are written in vertex form, we can do our transformations. That's how B and C were written. A was written in standard form, and if it's in standard form, we need some other options for how to graph it. So there's actually a formula that can be used to find the vertex. You guys did it last year in Algebra 2. Do you remember? Anyone remember? The x value of the vertex is equal to? So it'll be over 2a. Yep. So we can use that to find the x. There is a formula for y, but I don't like to memorize more than we have to. So I'm just going to say you plug x in to get y. Okay, so if you look at Math Excel, sometimes it gives you a second formula to use to find the y value of the vertex. Just find x, then plug it in to get y. Remember, the vertex is always an ordered pair. Axis of symmetry is a vertical line that goes through the vertex. We weren't really graphing it on these, but when we're using the formula, we usually will. The axis of symmetry, you could just draw it and know that it's the same on both sides. So it cuts down on the number of points you have to find. Since it's a vertical line, it's written as x equals, and it's the same as the x value of the vertex. So it's just x equals the opposite of b over 2a. But you have to give me the full equation for the axis, not just a number. Then we'll find the y-intercept to complete our graph. A y-intercept is where the graph touches the y-axis. So how would you find that? Okay, if it's the point where it touches the y-axis, if it's on the y-axis, what's x equal to?
0.
So to find the y-intercept, we'll plug 0 for x. And And from those three pieces of information, we'll be able to get the graph of our parabola. So let's try a few. So I want the vertex, axis of symmetry, y-intercept, domain, and range. You'll find a lot of information here. So our vertex, we're going to start out doing x equals the opposite of b over 2a. What's my b value? Okay. And so the b is just the 2 in front. So it's the opposite of 2 over 2 times. A is a number in front of x squared, so that's just 1. So we get negative 2 over 2, or negative 1. The vertex is an ordered pair. We have the x. So how do we find the y? Plug it into the equation. So negative 1 squared plus 2 times negative 1 plus 5. So we get 1 minus 2 plus 5, which is 4. So my vertex is the ordered pair negative 1, 4. Okay, the axis of symmetry, the vertical line that goes through it. So it's a line, it's always x equals, and it's just the x value of our vertex, which is negative 1. Yes?
It says -5 instead of +5.
Oh, thank you. It would help if I wrote down the problem right, wouldn't it? Okay, so 1 minus 2 minus 5 will give me negative 6. So how about negative 1, negative 6? Vertex is that point. The axis of symmetry, the vertical line going through it, x equals negative 1. We typically draw that as a dashed line. Okay. Any graph that I ask you to draw, I require at least 3 exact points. We currently have 1, so I can't finish my graph yet. Let's find the y-intercept. How do we find a y-intercept? So if we put in 0 for all the x's, we get negative 5. So we hit the y-axis at negative 5. Okay, this is really all we need to get our graph, because the axis of symmetry cuts it in half. It's the same on both sides. So my y-intercept is 1 to the right of the axis of symmetry. So then another point would have to be 1 to the left. I think that just reflecting it over the x-axis, or that axis. You could draw it from here. If you didn't feel comfortable, you could always plug in more points. Like for instance, if I put in a 1, I get out negative 2. If you're trying to reflect that one, it's 2 away from the axis of symmetry. So if you go 2 the other direction, that gives you another point. So you at least have to have the vertex, the y-intercept, and the axis of symmetry plotted. And then you can reflect your y-intercept over. If you need more points, you can always put in more. What's the domain of this? Every time. What's my range?
-6.
Does this have a maximum or a minimum? Of what is my minimum value?
-6.
Good. Okay. I want you guys to try B. So, do the same thing. See if you can find the vertex, axis of symmetry, and y-intercept on that one. So the opposite of B. B is negative 6. The opposite of negative 6 is 6 over 2 times A. A is the number in front of x squared, so that's 4. So we get 6 over 8, which is 3/4. So that's the x value. To get y, you plug that in. And what do you get? Do we all agree with that? So 3/4, 19/4 is like 4 3/4. So it doesn't work out perfectly, but we can estimate it. The axis of symmetry then is the line going through that, so just x equals 3/4. Make sure you put the x equals. And then we graph that as a dashed line. Y-intercept, if you put in 0 for all of your x's, we get 7. If you're trying to get your graph from here, how far is this point from the axis of symmetry? 0.75, 3/4. So if you go 3/4 or 0.75 the other direction, that takes you to 1.5. So that's our graph with at least 3 exact points. And if you have trouble reflecting it, you can always just plug in another number or 2 to get your graph. So that is fine once you have your vertex. What's my domain? What's my range? Right, 19/4 or 4.75 to infinity. Does this one have a maximum or minimum? Of, what is that minimum value? Yep, the 19/4 or 4.75. Good. Questions so far? Let's try one more. Actually, can I do some things out of order? I want to do this one tomorrow. I want to go and do A of this example instead. So I want to see if we can look at this equation and answer some questions. So the vertex, we should know how to do that by now. What do I have to do first? So the opposite is 6 would be -6 over 2 times -3. So -6 over -6 is 1. And then to get y, you plug in a 1. You get -3 plus 6 plus 1, which gives me 4. So my vertex is 1, 4. What's the axis of symmetry? 1, but how do I have to write it? X equals 1, because it's a line, so you have to give the full equation of the line. Okay, does this parabola open up or down?
Down.
Since we have a negative on the x squared, it will open down. So if it's opening down, would it have a maximum or a minimum? What is that maximum value? Good. This vertex is 1, 4. Your maximum is your y value. So your maximum is 4. All right, I am going to stop here for today. There is a Math Excel assignment that you can do the whole thing.